Hello everyone and welcome back to our videos. Today we are going to talk about fuel system indicators. Chapter 14 AIRFRAME book. We have four instruments for indicating fuel systems. The first one, fuel quantity gauge. The second one, fuel pressure gauge. The third one, fuel temperature. The last one, fuel flow indicator. Today we will gonna talk about fuel quantity gauge on large aircraft and small aircraft. All aircraft fuel systems must have some form of fuel quantity indicator. These devices vary widely depending on complexity of the fuel system and the aircraft on which they are installed. Simple indicators requiring no electrical power were the earliest type of quantity indicators and are still in use today. The use of these indicator readings indicators is only on light aircraft in which the fuel tanks are in close proximity to the cockpit. Other light aircraft and larger aircraft require electric indicators or electronic capacitance types. And this is what we are going to talk about today. We have a mechanical fuel quantity gauge, and they are common and they have a float that follows the fuel level, remains the primary sensing elements, but a mechanical linkage is connected to move a pointer across the dial face of the instruments. This can be done with a crank and pinion arrangement that drives pointer with gears. We have gears for drive the pointer, or with a magnetic coupling to pointer. The magnetic coupling to the pointer, we will see it in the next figure. Here in this figure we have a magnet that will move our pointer. The second type we have it called electric fuel quantity indicators, and they are common than mechanical indicators in modern aircraft. Most of these units operate with direct current and use variable resistance in the circuit to drive ratio meter type indicator. The movement of a float in the tank moves a connecting arm to wiper on a variable resistor in the tank unit. Here we have the wiper and here we have our tank resistance. This resistor is wired in series with one of coils of ratio meter type fuel gauge in the instrument panel. It changes the current flowing through the tank unit resistor. It changes the current flowing through the coil. This alerts the magnetic field in which the indicating pointer pivot, the calibrated dial indicator, the corresponding fuel quantity. The third type called capacitive type fuel probes, and they used in many modern aircraft. The use of the unit capacitor, a reference capacitor, and a microchip bridge circuit in the fuel quantity indicators is complicated by the fact that temperature affects the dielectric constant of the fuel. A compensator unit mounted low in the tank, so it is always covered with fuel, is wired into the bridge circuit through a reference circuit to the bridge circuit. It modifies current flow to reflect temperature variations of the fuel, which affect fuel density and thus capacitance of the tank units. An amplifier also is needed in older systems. The amplitude of the electric signal must be increased to move the servo motor in the analog indicator. Additionally, dielectric constant of different turbine engine fuels approved for particular aircraft may also vary. Calibration is required to overcome this. So here our probes, it will give and signals for the quantity of fuel into the tank and will send it to the bridge. The bridge circuit will move it to the amplifier. The amplifier will increase the signals and send it to the motor for move our needle. Here, when we see the compensator here, it will make a balanced signals between the probes, because if we have a maneuvering or banking for the aircraft, the probe will sense increase or decrease in fuel, but the compensator will correct this by sending signals to a reference circuit, and the reference circuit will send it to the bridge circuit, and it will make balance between the fuel probe signals and the compensator signals. And of course it's electrical signals use here, the input of our electrical signals. At the end, most large transport aircraft have a means for personnel to manually gauge the amount of fuel in the tank. One method uses magnetically locked fuel measuring stick. To check the fuel quantity using one of these devices, turn the latching cam on the bottom surface of the wing tank a quarter of turn and pull down the measuring stick until the magnet on the measuring stick meets the magnet in the float. Here we have the magnet, and here we have our latching cam. You will turn this a quarter and you will let the stick to move down. Here we have a float or magnetic float, and we have the stick magnetic. When this magnetic will meet this magnetic of the float of fuel, it will stop and the indicator will goes in the stick, and you will can see the fuel quantity. Also, you can feel when the magnets grip together and read the number on the measuring stick that related to the fuel level in the tanks.